James Webb Telescope captures terrifying city lights on Proxima B. Imagine standing on a distant world where endless night stretches in every direction, an abyss of darkness. Yet, within this eternal shadow, faint lights shimmer, not chaotic, but arranged in patterns that seem eerily deliberate, like the glowing cities we see from space on Earth. This is no fictional world, it's Proxima B, a rocky planet orbiting our closest star, just 4.24 light-years away. Thanks to the remarkable James Webb Space Telescope, we've captured images that hint at something astonishing. A network of lights on Proxima B's dark side. Could these be the lights of an advanced civilization, thriving silently in the shadows of a distant star? Or is there another explanation lurking just out of reach? This discovery has the power to challenge everything we know about life in the universe. Join us as we explore this mystery, unravel its secrets, and dare to ask, are we truly alone, or are we on the brink of encountering a cosmic neighbor? Part 1. Background and Initial Discovery. Proxima B, a world cloaked in mystery, orbiting our closest stellar neighbor, Proxima Centauri, just 424 light-years away. Discovered in 2016 by the European Southern Observatory's La Silla Observatory in Chile, this rocky exoplanet sparked immense excitement among scientists and dreamers alike. Why? Because Proxima B orbits within the habitable zone, the region around a star where conditions might allow liquid water to exist on a planet's surface. With a mass 1.17 times that of Earth and a similar composition, Proxima B quickly became the best candidate for potentially harboring life beyond our solar system. However, Proxima B's environment is anything but gentle. It orbits extremely close to Proxima Centauri, a mere 7.5 million kilometers away, about 20 times closer than Earth is to the Sun. This proximity exposes the planet to intense stellar flares and radiation. Some scientists believed such conditions would render Proxima B uninhabitable, yet hope persisted. If life found a way to thrive there, it would be remarkably resilient. Enter the James Webb Space Telescope, JWST, the most advanced space observatory ever created. With its cutting-edge infrared technology, JWST peered into the darkness of Proxima B's night side, and what it found was astonishing. Faint glimmers of light appeared, not scattered randomly, but arranged in a deliberate grid-like pattern. These lights were eerily reminiscent of cityscapes on Earth seen from orbit. Astrophysicist Dr. Lisa Kaltenegger from Cornell University remarked, "If these lights are artificial, it would suggest the presence of a technologically advanced civilization. We've never seen anything quite like this before." The discovery sent ripples of excitement and skepticism through the scientific community. Was this truly evidence of an alien civilization? Or could there be a natural explanation we hadn't considered yet? Natural phenomena like volcanic activity, lightning storms, or bioluminescence were proposed. But these theories quickly hit obstacles. Volcanic eruptions produce erratic, short-lived bursts of light. Lightning is brief and chaotic, and bioluminescence, while fascinating, would require an unimaginably vast network of organisms emitting light in a perfectly synchronized manner, an unlikely scenario on a planetary scale. What JWST captured was something different: consistent, organized, and structured illumination. Dr. Avi Loeb, a theoretical physicist at Harvard University, noted, "The regularity of these patterns makes it hard to dismiss the possibility of artificial origins. If nature isn't the artist, then who or what is?" This discovery on Proxima B challenges our very understanding of life in the universe. If these lights are indeed artificial, it means that intelligent civilizations may not be as rare as we once believed. The implications are staggering, raising questions about technology, communication, and the potential for civilizations to thrive in environments we once deemed hostile. As we stand on the brink of this revelation, the mystery deepens. Are we seeing the handiwork of an alien society flourishing in the shadows, Or is there another explanation waiting to be uncovered? The search for answers has only just begun, and the universe has never felt more alive with possibilities. Part 2. Hypothesis of artificial lights. When the James Webb Space Telescope captured the faint, shimmering lights on Proxima B, it wasn't the mere presence of light that astonished scientists, it was the patterns. These lights weren't scattered haphazardly, like the chaotic bursts of a lightning storm or the fleeting glow of volcanic eruptions. Instead, they formed a grid-like structure, a mesmerizing network that hinted at deliberate design. Imagine looking down at Earth from space and seeing the lights of New York or Tokyo. This was strikingly similar. The lights on Proxima B appeared organized, continuous, and purposeful. This regularity immediately ruled out many natural explanations. For example, volcanic activity can produce light, but it's erratic and temporary, fading as quickly as it appears. Lightning storms, though powerful, are unpredictable and inconsistent. And while the idea of bioluminescent organisms on a planetary scale is fascinating, it's also improbable. For such a vast expanse of synchronized light, Proxima B would need an ecosystem unlike anything we've ever seen, a planetary biosphere teeming with life forms glowing in perfect unison. Highly unlikely. So if these lights aren't natural, what else could they be? The idea that sends shivers down our spines is this: they might be artificial. Could it be that these lights are the product of an advanced civilization, a society capable of illuminating their world on a massive scale? If true, this would be the first solid evidence of intelligent life beyond Earth, a discovery that would forever alter our understanding of the cosmos. Astrophysicist Dr. Sarah Seeger of MIT remarked, "We've always wondered if we're alone in the universe. If these lights are artificial, it suggests that life isn't just a rare cosmic accident. It could be thriving, perhaps even flourishing, just a stone's throw away in astronomical terms." The implications are profound. If a civilization on Proxima B exists and has harnessed technology to create planetary-scale illumination, it tells us several things. First, it implies that the development of advanced technology might be a natural trajectory for intelligent life, that we're not unique in our capacity to create and innovate. Second, it raises the possibility that such civilizations are more common than we've dared to believe. This brings us to the Fermi paradox, the perplexing question posed by physicist Enrico Fermi in the 1950s. If the universe is teeming with potential life, where is everybody? The discovery of artificial lights on Proxima B might be a clue to unraveling this paradox. Perhaps intelligent civilizations are out there, quietly existing, their signals faint, and their worlds shrouded in the kind of darkness that only the most advanced telescopes can penetrate. One explanation could be that these civilizations are deliberately keeping a low profile, avoiding broadcasting their presence to the cosmos, a concept known as the dark forest theory. In this scenario, civilizations stay hidden out of fear of attracting unwanted attention. If the lights on Proxima B are artificial, they could be evidence of a society that illuminates its world just enough for survival, but not so much as to announce its presence to the universe at large. Alternatively, the lights might represent a civilization that's simply too far removed from us technologically for their signals to align with our detection methods. As Dr. Avi Loeb from Harvard speculates, we might be like early humans listening for drumbeats while an advanced civilization is transmitting via radio waves. If this is the case, our current technology might only be scratching the surface of what's out there. But what if these lights aren't just for survival? What if they're a form of communication, a beacon deliberately designed to be seen by other intelligent beings? A cosmic lighthouse, signaling across the vastness of space. Could it be that Proxima B's inhabitants are reaching out, unaware that we've finally developed the eyes to see their message? Of course, skepticism is healthy. Extraordinary claims demand extraordinary evidence, and while these lights are compelling, they are not yet definitive proof. further observations are needed. Upcoming missions, such as the Breakthrough Starshot initiative, aim to send small, light-propelled probes to the Alpha Centauri system, offering a closer look at Proxima B and its enigmatic lights. Whether these lights are the product of nature or a civilization, the discovery on Proxima B challenges us to keep searching, to keep questioning, and to remain open to possibilities that stretch the limits of our imagination. Perhaps in this tiny flicker of light, we are glimpsing not just another world, but a shared destiny, a reminder that the universe is far more mysterious and wonderful than we ever dared believe. Part 3. Challenges of a hostile environment. Proxima B, though promising in its potential for life, exists in a realm of relentless challenges. Orbiting the red dwarf star Proxima Centauri, just 4.24 light-years away, this rocky planet finds itself in a cosmic neighborhood ruled by extremes. Unlike our steady and life-sustaining sun, Proxima Centauri is a tempestuous star. It frequently unleashes powerful stellar flares, intense bursts of radiation that send shockwaves across its planetary system. For Proxima B, these flares are not gentle flickers, but violent storms that could be hundreds of times more powerful than those on Earth. Imagine standing on Proxima B's surface, where daylight is dim, and the sky suddenly erupts with blinding light and deadly radiation. These flares release torrents of X-rays and ultraviolet radiation, powerful enough to strip away the planet's atmosphere over time. Dr. Paul Rimmer, an astrobiologist at the University of Cambridge, describes it starkly. The radiation environment around Proxima B is a nightmare. Life, as we know it, would need extraordinary adaptations to survive there. These flares pose a severe risk of atmospheric erosion. Proxima B's proximity to its star, a mere 7.5 million kilometers, means it is constantly bombarded by stellar winds. Without a strong magnetic field, these winds could gradually peel away its atmosphere, leaving the surface exposed to the vacuum of space. This raises an unsettling question. How can life endure under such brutal conditions? Yet life is nothing if not resilient. On Earth, extremophiles, organisms that thrive in extreme environments, have shown us that survival is possible in the most inhospitable places. Could life on Proxima B have adapted similarly? One possibility is that any living organisms have retreated underground, where they can shelter beneath layers of rock and soil, safe from radiation. In these hidden depths, geothermal heat could provide the energy needed for survival, much like the ecosystems found around deep-sea hydrothermal vents on Earth. But what if we're not just talking about microbial life? If the lights observed by the James Webb Space Telescope are indeed artificial, they suggest the presence of an advanced civilization, one that has faced these environmental challenges head-on and found ways to thrive. Perhaps this civilization has constructed vast subterranean cities, illuminated by artificial lights, where life continues far from the deadly surface. These underground refugees might be connected by intricate tunnels, with entire ecosystems flourishing below ground, shielded from the wrath of their star. Dr. Michaela Musilova, a planetary scientist and analog astronaut, speculates, if intelligent life exists on Proxima B, it would have needed to innovate rapidly. Building underground habitats or developing radiation shields wouldn't be optional. It would be a matter of survival. This hypothetical civilization might have developed advanced shielding technologies to protect not just their homes, but also their agriculture and infrastructure. Imagine domed cities covered in materials designed to deflect radiation or absorb harmful particles. Fields of crops growing under the glow of synthetic sunlight, protected by transparent shields that let in light but block harmful rays. Another possibility is the use of planetary-scale engineering to maintain or replenish their atmosphere. If Proxima B's inhabitants possess sophisticated technology, they may have developed artificial magnetic fields to shield their planet, much like Earth's natural magnetosphere protects us from the solar wind. This kind of atmospheric defense would require enormous energy and resources, but it could be the key to sustaining life on the surface. But what if the civilization didn't start underground? What if Proxima B was once a more hospitable world, with clear skies and thriving ecosystems? Over millennia, as Proxima Centauri's flare activity intensified, the surface may have become uninhabitable, forcing the civilization to adapt or face extinction. This paints a sobering picture. A society that once basked in the light of its star, now confined to the shadows, fighting to preserve its way of life. Such resilience speaks to the remarkable tenacity of intelligent life. If Proxima B's civilization exists, it stands as a testament to the power of adaptation, innovation, and survival against impossible odds. And in their story, we may find echoes of our own future. As humanity faces challenges like climate change, radiation threats, and the potential for space colonization, the solutions imagined for Proxima B, underground living, radiation shielding, atmospheric engineering, could one day become our reality. Of course, this is all speculation. The lights observed might yet have a natural explanation, and the true nature of Proxima B remains a mystery. But whether through biological adaptation or technological ingenuity, any life on this distant world must possess a breathtaking will to survive. The mere possibility of such a civilization inspires us to keep searching, to keep questioning, and to imagine what lies beyond the veil of darkness. In the end, the story of Proxima B is not just about a distant planet. It's about the universal struggle for survival. It's a reminder that life, once sparked, has an incredible capacity to endure, to adapt, and to thrive, even in the face of overwhelming challenges. And perhaps in the faint glimmers of Proxima B, we are glimpsing not just another world, but a reflection of our own potential, our own resilience, and the boundless possibilities that await us in the cosmos. Part 4. Radio signals and the potential for contact. In December 2020, a strange signal was detected by the Breakthrough Listen initiative, a project dedicated to scanning the cosmos for signs of extraterrestrial intelligence. The signal, known as BLC-1, Breakthrough Listen Candidate 1, appeared to come from the direction of Proxima Centauri, the very star that Proxima B orbits. What made BLC-1 particularly intriguing was its narrow frequency of 982.02 MHz, a frequency not typically produced by natural cosmic phenomena. The signal was steady, unmodulated, and persisted for several hours, characteristics that hinted at a potential artificial origin. When news of BLC-1 broke in 2021, the scientific community buzzed with excitement and skepticism. Could this be the long-awaited evidence of an intelligent civilization trying to reach out? Dr. Sophia Sheikh, an astronomer involved in analyzing the signal, commented, "BLC-1 is unlike any signal we've detected before. While we haven't confirmed it as extraterrestrial, we can't rule out the possibility that it came from a source with intelligence behind it." BTPs, na www.ct.org. Sites are default. Files, inline images, Sophia Sheikh, JPG. The characteristics of BLC-1 fueled intense speculation. Unlike pulsars or quasars, which emit radio waves at varying frequencies, BLC-1 was a stable signal, unwavering and focused. This stability suggested that it might be a deliberate transmission, a form of communication akin to a beacon. Imagine a civilization on Proxima B sending out a steady pulse, like a lighthouse guiding ships through a dark sea. Except this sea is the vastness of space, and the ships are our radio telescopes. But what if BLC-1 isn't a greeting, but a warning? The idea of a warning signal sent chills through the scientific community. Perhaps this civilization has faced dangers we can barely comprehend, hostile forces, cosmic catastrophes, or even the threat of self-destruction. And they're broadcasting a message of caution. Could they be telling us to stay hidden, to avoid making the same mistakes? The possibility of contacting an advanced civilization raises profound questions and potential risks. Dr. Stephen Hawking, the renowned physicist, famously warned of the dangers of announcing our presence to the cosmos. He compared such an act to Native Americans encountering Columbus, an encounter that didn't end well for the less advanced civilization. Hawking's caution underscores a sobering thought. If a civilization is capable of interstellar communication, they may also be capable of interstellar conquest. Imagine making contact with a society centuries or millennia ahead of us in technology. Their motives, ethics, and values might be entirely different from ours. Would they see us as equals, potential allies, or something else? A resource to exploit, a threat to neutralize, or a curiosity to observe? The lights on Proxima B, if artificial, suggest a civilization that has mastered energy on a planetary scale. If they've survived the harsh environment of Proxima Centauri, they are likely resilient, resourceful, and perhaps cautious about who they interact with. Yet, despite these risks, the allure of contact is irresistible. The potential to learn from a civilization that has survived and thrived in such a challenging environment could offer invaluable insights. Their knowledge of sustainable energy, radiation protection, and long-term survival strategies might help us solve some of our own pressing challenges on Earth. Could they teach us how to harness energy more efficiently, protect our planet from cosmic threats, or even travel beyond our solar system? The debate over whether to respond to potential signals like BLC-1 is ongoing. Some scientists advocate for passive listening, arguing that we should observe and learn without revealing our presence. Others believe that active communication, sending messages to the stars, is a natural extension of human curiosity and exploration. Projects like METI, Messaging Extraterrestrial Intelligence, aim to craft and send carefully considered messages, hoping to establish contact while minimizing risks. However, the stakes are high. The cosmos is vast and ancient, and we are newcomers on this stage. A careless message, a signal sent without consideration of the consequences, could attract attention we're not prepared to handle. Dr. Jill Tarter, a pioneering SETI researcher, puts it succinctly: we need to think carefully about who we're trying to talk to and what we want to say. As we ponder BLC-1 and the lights of Proxima B, we are caught between hope and caution, curiosity and fear. Are we ready for contact? Do we have the wisdom to navigate such an encounter, or are we like children playing with a radio, unaware of who might be listening? For now, the signal remains a mystery. Whether it's a beacon, a warning, or a product of cosmic coincidence, it challenges us to consider our place in the universe. It reminds us that we are part of something much larger, a cosmos filled with potential neighbors, dangers, and wonders. The journey to uncover the truth has only just begun, and every signal, every light, brings us one step closer to answering the age-old question: are we alone? Part 5. Philosophical and cultural implications. The potential discovery of artificial lights on Proxima B is more than just a scientific revelation. It has the power to shift the way we understand ourselves and our place in the universe. For centuries, humans have stood at the edge of the unknown, wondering if we are alone. Now, with evidence suggesting that a civilization might exist just over 4 light years away, this question is no longer abstract. It feels immediate, tangible, and deeply personal. Throughout history, we have believed ourselves to be unique, perhaps even exceptional. Every major discovery, from realizing that the Earth orbits the Sun to the idea that our galaxy is just one of billions, has forced us to adjust our perspective. The possibility of intelligent life on Proxima B challenges us once again. If another civilization has risen on a distant world, it means that the universe is not just vast, but also filled with potential for life. We are not the lone thinkers in a silent cosmos. we may be part of a vibrant, interconnected galactic community. This revelation touches on fundamental philosophical questions. Who are we? Why are we here? Are our struggles, achievements, and hopes part of a larger cosmic story? These questions, long pondered by philosophers and theologians, take on new urgency. If there are other civilizations, what paths have they taken? Have they overcome challenges similar to ours, or have they faced obstacles we have yet to encounter? Their existence might hold a mirror up to humanity, reflecting both our potential and our limitations. Religions around the world have long offered answers about humanity's place in creation. The discovery of intelligent life beyond Earth could lead to profound reflections within these belief systems. For some, it may be seen as a threat to traditional doctrines. If God created humans in His image, what does it mean if other intelligent beings exist? Are they also part of the divine plan? Yet for others, this discovery might expand their understanding of the divine. The universe, with its billions of galaxies and endless possibilities, may be seen as a more magnificent creation than previously imagined. Brother Guy Consolmagno, the director of the Vatican Observatory, once remarked, "If we discover intelligent life, it won't diminish God's greatness, it will only expand it." Faith, rather than being challenged, might be deepened by the realization that life flourishes in many forms across the cosmos. Culturally, the discovery of another civilization could spark a new age of artistic and intellectual exploration. Throughout history, great discoveries have ignited creative revolutions. The Renaissance, driven by the rediscovery of ancient knowledge and new understandings of the cosmos, led to masterpieces in art, literature, and science. A similar renaissance could be on the horizon, inspired by the realization that we are not alone. Imagine literature that explores the lives, hopes, and dreams of beings on Proxima B. Films and music might reflect the wonder and mystery of this discovery, blending human stories with those of our cosmic neighbors. Artists could draw inspiration from the idea of otherworldly civilizations, imagining their cities, landscapes, and cultures. This creative surge could help us process the profound implications of not being alone, offering new ways to connect with the cosmos and each other. More importantly, the possibility of intelligent life beyond Earth could serve as a unifying force for humanity. On a planet often divided by borders, ideologies, and conflicts, the realization that we are part of a larger universe might encourage a sense of shared identity. Dr. Frank Drake, the pioneer of the search for extraterrestrial intelligence, believed that the discovery of alien life could remind us of our common humanity. In the face of the vastness of space, our differences seem small. We are all passengers on a fragile blue planet, united by the same challenges and aspirations. This sense of unity could lead to increased international cooperation in space exploration. Nations might come together to share resources, knowledge, and technology, driven by a common goal: understanding our place in the universe. Programs like the United Nations Office for Outer Space Affairs, UNOOSA, could play a key role in coordinating global efforts to explore and communicate with potential civilizations. New treaties might be needed to govern how humanity approaches first contact, ensuring that we act with caution, respect, and responsibility. Yet this discovery also challenges us to reflect on our own civilization. Are we ready for contact? What message would we want to send to another intelligent species? Our history is filled with both triumph and tragedy, cooperation and conflict. If we are to meet another civilization, we must strive to present the best version of ourselves, a species capable of kindness, curiosity, and wisdom. Ultimately, the lights on Proxima B are more than just a distant mystery. They are a reminder of the endless possibilities that await us in the cosmos. Whether or not these lights are the product of an intelligent civilization, The search itself pushes us to expand our minds, challenge our beliefs, and imagine a future where we are part of a larger cosmic community. As we stand on the brink of this new era, we are reminded that the universe is not just a cold, empty void. It is a place of wonder, mystery, and potential. The journey to discover what lies beyond our world is also a journey to discover who we are and who we might become. In the glow of those distant lights, we find both a challenge and an invitation to look beyond ourselves, to dream boldly, and to embrace the infinite possibilities of existence. The James Webb Space Telescope's discovery of potential city lights on Proxima B has opened a doorway to endless questions. Are we truly alone, or are we on the edge of a cosmic revelation? Future missions and advanced technologies promise to unravel these mysteries, leading us into a new era of exploration and wonder. What incredible discoveries lie ahead? Will we find neighbors among the stars or new challenges to overcome? If you love diving into the mysteries of space, don't forget to like, share, and subscribe. Join us on this thrilling journey as we continue to explore the boundless unknown.